Dear students, I, Dr. Y.S. Dangi, going to present you a lecture on product generation in GIS, that is Geographic Information System, tools for map analysis, integration of GIS with remote sensing. First of all, let us start with introduction. Here we will focus on integration of remote sensing and geographic information system for making it users friendly, as well as the application of both technologies for modeling and decision support. The discussion will range from simple visualization to data extraction and database development and analysis based on multi-source data. This will benefit from advances in computing, hardware and software, and global positioning system, that is GPS technology, besides development in theory and analytical methods, including innovations in use of decision trees, neural networks and evidential reasoning. Integration of data derived from remote sensing and GIS data. The aerial photography has long been used to generate analog geospatial products that now in a digital form constitute important components of GIS databases. With the advent of digital remote sensing systems and image processing software, the importance of remote sensing in GIS has expanded considerably. Applications of remote sensing range from the use of ortho imagery as a GIS based layer to the development of the thematic data on land use and the generation of unique geospatial datasets via extraction of cartographic features such as buildings and roads from imagery. Now, coming to preparation of ortho imagery as base data for GIS. In a GIS database, all features must be positioned as accurately as possible. Additionally, all data layers must be registered to one another and should be geo-referenced to a specific map projection and coordinate system. Base maps provide the frame of reference for positioning, registration and geo-referencing. In recent years, ortho images generated from aerial photograph, that is digital ortho photos or fine spatial resolution satellite data, have been used as base layers. Such images have been corrected to remove relief displacements arising from sensor perspective and topographic relief. Developing thematic database for GIS. Remote sensing data has become the primary source for preparation of thematic data to GIS analysis, which includes data on land use and land cover characteristics and surface elevation. Aerial photos and satellite imagery are being used to assess the landscape development for updating existing geospatial databases, example roads, hydrography, etc. Details on methods used to create geospatial data from remote sensing have been discussed in many books and on various websites. Now, we will highlight with a few examples of thematic geospatial data derived via remote sensing. Surface elevation. DEM, that is digital elevation module, DTM and DSM, that is digital surface module, are widely used in geographic information system. We know that photogrammetry has been used as the main source by which surface elevation is mapped, although aerial photography has already been used in such work now. Satellite imagery acquired by ECONOS, that is commercial earth reading satellite, and ASTER, that is advanced space imagery thermal emission radiometer, has become most useful in terms of resolution and accuracy. Land use and land cover mapping. Land cover dataset, that is NLCD, are being widely used in GIS analysis, which were based mainly on classification of Landsat imagery. Many advances in land use and land cover mapping are connecting with new methods of analysis founded on integration of remote sensing and GIS data. Biophysical phenomena. Remote sensing is being used to provide unique thematic data like of biophysical characteristics including surface temperature, imperviousness, water clarity, evapotranspiration, vegetation pigments, biomass, canopy structure and height, leaf area index, that is LAI, and soil. These data are required for GIS based hydrologic, meteorological, wildfire risk and crop simulation modeling. Biophysical data derived from sensors such as MODIS, that is moderate resolution imaging spectroradiometer, has become main inputs to global scale biophysical models to say about carbon dynamics and ecosystem. Feature extraction. In remote sensing, feature extraction procedures are being used to automate identification and mapping of physical objects. Example, buildings, roads. These procedures are now in practice to update or increase accuracy of existing GIS databases or to create new data layers. Landscape change. Remote sensing provides assistance to identify and map changes in geospatial features. Now, aerial and satellite remote sensing are being used for updating GIS databases on land use, hydrography and transportation networks. Impacts of natural hazards such as hurricanes and progression of dynamic processes such as soil erosion can also be assessed using remote sensing. Multi-temporal data are used to monitor seasonal and interannual landscape events at local, regional and global levels. Now, coming to another important part of the discussion, that is application of geospatial data in remote sensing and geographic information system. Geospatial datasets showing phenomena such as surface elevation, soils, transportation, hydrography and land use are the main features of geographic information systems. Although such datasets are most often developed through analysis of aerial and satellite imagery. In remote sensing, they are generally considered as ancillary data. Digital elevation models are being used frequently in such work. Geometric correction and ortho rectification. Images acquired through remote sensing show spatial displacements of objects and scale variations that relates with sensor orientation and topographic relief. Such displacements are removed in order to create a planimetrically correct, that is ortho rectified image, that is an image that has properties similar to a map such as consistent scale. Software for creating digital ortho images is a base for many image analysis, but data required for rectification including geodetic control often obtained by a GPS and digital elevation data are imported from GIS. Radiometric correction. Spectral reflectance from the Earth's surface is a complex function of land cover, angle of solar illumination, atmospheric condition and topographic position, that is slope and aspect. In a given image, the brightness values for pixels of the same land cover type can vary substantially depending on whether they are situated in full sunlight, example south facing slopes in the northern hemisphere, or shadow. These effects are especially evident in areas of high relief. If such artifacts are not removed, they can significantly degrade results of multispectral classification. Image classification. The generation of ortho imagery and topographic normalization demonstrate a form of remote sensing GIS integration. The most sophisticated types of integration is represented in digital image classification and modeling. The main aim of image classification is to enhance information extraction and thematic mapping by means of data fusion and multi-source analysis. Enhancement shows improving the accuracy and or categorical resolution of products traditionally generated solely from multispectral analysis of digital, aerial or satellite imagery. We added various methods to integrate GIS with remote sensing to improve extraction of information from digital images, which include image stratification, classification, modification, post classification sorting and advanced methods for multi-source data analysis. Image stratification. Stratification is a procedure for subdividing an image into regions of internally homogeneous areas, that is strata. In digital image analysis, one approach is to use geospatial data for stratification and to classify each stratum separately. Classification modification. Most image classification relies on use of parametric supervised or unsupervised classification techniques. A number of investigators have developed methods by which ancillary data can be integrated with imagery and used to improve multispectral classification. Post classification class sorting. The important land cover classes and conditions may be spectrally inseparable using conventional classification algorithms. Hence, some spectral classes may need to be combined for cartographic purposes. Map analysis tools, that is spatial analysis tools. Spatial analysis is the process of modeling and obtaining results through computer processing and then examining and interpreting the results. Therefore, it is useful for assessing suitability and capacity for calculating, predicting and interpreting and understanding the spatial phenomena. Interpolations. Interpolation is a process that uses measurements made on some phenomena like precipitation, temperature, elevation in certain places such as samples or stations to make a prediction for the same phenomena in places where no measurements have been made. There are many methods of interpolation, some of which have been widely adopted in GIS for handling of data. The following tool can be used, that is, select ARC toolbox, go to Spatial Analysis Tools, then select Interpolation. Digital elevation models. A digital elevation model, that is DEM, is a raster representation of a continuous surface. It usually refers to the earth's surface using a set of points whose x, y and z values are known and defined in an arbitrary coordinate system. The information that can be derived from digital elevation models can be applied in different fields such as hydrology, risk analysis, urban planning, among others. The main products that can be obtained from a DEM are slope maps, contours, relief maps, visibility maps, aspect maps, watersheds, viewshed, etc. Creation of slope maps. Slope is the main factor that determines and differentiates the shapes of the landforms. Thus, the slope of the terrain is in terms of mathematical ratio determined by the proportional relationship between the difference in altitudes and the horizontal distance between 2 points. The slope can be expressed in percent or sexagesimal degrees. To create the raster map of a slope, a DEM is required as input information and the slope tool is used to generate the slope raster using the following method. First, select ARC toolbox, go to Spatial Analysis Tools, then select Surface and finally Slope. Reclassifications. The Reclassify tool allows the values of a raster to be reclassified. That is, it replaces the current values of each cell with new information. Data can be reclassified from any variable stored in the raster format, that is slope, elevation, precipitation, temperature, etc. To run the reclassification, open the Reclassify tool as follows. Select Arc Toolbox, go to Spatial Analysis Tools, then go to Reclass and finally select Reclassify. Contour creation. Contours are the lines joining points of equal values that represent continuous phenomena, are also called as isolines. These are called contour lines when used to represent elevation. Isobars for atmospheric pressure, isoheight for precipitation, isotherms for temperature and isochrones for time. The process for generating isolines of all kinds is similar. If you need to create contours, you need a DEM as input information. The isolines are generated with the contour tool as follows. First select Arc Toolbox, go to Spatial Analysis Tools and then select Surface. Map algebra. The raster layer calculator or simply raster calculator is used to run algebraic expressions using various tools and operators through the interface of a simple calculator tool, that is raster calculator tool. The performance of equations depends on the tools or operators involved in an expression. The versatility of the map algebra lies in its simplicity and power to perform geographical analysis. A raster layer can be created from an algorithm by assigning numerical values to the pixels that compose it, or it can be derived from one or more previously existing raster layers. Design and publication, that is product generation mapping, can be a laborious process until you get the right result. Viewing data to analyze and interpret spatial information on a computer is one thing, but printing a map for others to analyze and interpret is quite different. ArcMap makes available a number of tools for map design prior to publication. In general, the simpler a map is, the easier it is to understand. This means avoiding unnecessary content, selecting appropriate colors, selecting the correct text size and prioritizing information according to its relevance. In other words, it is not just a matter of creating a map for the user, but also for convey the purpose for which it has been designed. A map is a representation or perception of the territory. It offers the user only what the cartographer wants to show. The designer selects the elements in a reasoned way which he wants to map, but his choice depends on his own knowledge, sensitivity and intentions. Symbology. Actually, it allows user to define how the selected elements can be displayed on the map using symbols, colors, frames, text, etc. It is decided whether or not the information is required to display according to the attribute table of each layer. Map design. It is impossible to transpose the real world onto a map. Therefore, the user has no option except to believe in it. The cartographer is completely free to transcribe the world as he sees, but in depicting reality one should not bias or manipulate information, but maintain as impartial as possible. The distribution of the elements of a map is subject to the cartographer's requirements. The important thing is that a map can be understood by the user segments. The layout of the map suggests that all elements are obligatory. At least it should also contain the title, grid, geographic, north scale and legend. To start designing the map, change the data view screen to layout view. From the view menu, it is important to note that what users see in the layout view, that how it will look when printing or exporting the map. Export and print a map. Once the mapping process is complete, a map can be printed or exported in various formats. To print the map, go to File menu, select Print and configure the printer. If user needs the map to be printed in another digital format, it is exported from the file using EMF, EPS, AI, PDF, SVG, BMP, JPEG, PNG, TIFF and GIF formats. The resolution and additional parameters can be configured in each format. In some cases, especially when special characters are available, a PDF file is not usually readable. We recommend using a PDF printer that is installed in the system. Summary: we have discussed on integration of remote sensing and GIS for making it users friendly, as well as the applications of both technologies for modeling and decision support. This section has covered from simple visualization to data extraction and database development and analysis based on multi-source data. This will benefit from advances in computing, that is hardware and software, and global positioning system, that is GPS technology, besides developments in theory and analytical methods, including innovations in use of decision trees, neural networks and evidential reasoning. Now, I do hope that you have learnt a lot about GPS technologies, use of GIS as a tool for map analysis, various surface elevation techniques and their applications. Thank you very much and have a nice day ahead.